Okay, so welcome back, my fellow YouTubers. Today we will be going over streaming a file from a Linux file system right back to a web page. So there's some circumstances. Sometimes maybe you have a log file that's generated on a Linux system and you want to just be able to get that out to a web page. So we can actually read the file, and as the file is being written, we can send that out to a web page. So you might want to stream a file that maybe users don't have access to, or you're writing something and you just want to have it available in a web format. So in this video we'll just kind of go through that. I make these videos so you can kind of take the concepts and the pieces and parts that you like and marry them together to create something that's extraordinary for you. So without further ado, let's get started. Let's open our VS Code and start creating some code. So we're going to be connecting to WSL, and if you look down in the description, I have a link to the video where I installed WSL on this virtual box running Windows 11. So before we get started, let's go ahead into our dev folder here, and let's create a folder called RTFS for real-time file streaming. So let's enter that folder and do a go mod in it. Put it in, but let's alright, so now that we have that folder created, let's go ahead and open it up here. Click on Dev Remote. Alright, so now we have the file open here. So let's create us a basic helper function here, and this is a bash script that's gonna create some log files for us. I'm gonna just paste this in. So pretty much this file, all it does is it takes a file name as a parameter, and it will just spit out what's currently the CPU utilization and memory on the current box. So if you look here, you'll see it spits out the date, the CPU, memory, open files, total files, and so it'll write that to the file of our choosing at a regular interval. And in this case we have it doing 0.2, which is about 5 times a second, or roughly. These commands actually take a second to run, so it won't be precisely that, but what we're simulating here is just write it as fast as possible. So let's test this out and just show you what we get, right? So if you look here, it says writing to temp sum log, right? So if you look here, it created a file called sum.log. So if we open that, you can actually see it's writing to that in real time, right? So pretty cool. So let's get out of there. Let's close that out. And first, let's just create a simple program that reads that file and outputs it in Go, so we can see that we can read a file from Go in real time. So let's get started. So let's create a function here that we'll call this basic file streamer. And this function will take a couple parameters, and it will be the file path as a string, and we'll take the output as a channel of type string. So first thing we'll do is we'll actually open a file here, and that will be that file path there. And so of course we have to handle our error there. We're gonna do, let's go ahead and fade on. So we'll just close the file once this function ends. There's no need to have it open after the function returns. So then what we want to do at this point is seek to the end of the file, right? So this is going to go to the end of the file and get any data that's in the file. And if there's an error, we also want to log out fatal. Then we want to create a new reader. So this reader will pretty much take the data that we read from the file here. So if you see here, we're just passing the file to read from the file, and then we'll create an infinite for loop. And in this for loop, we'll handle reading the file, and if there's nothing new, then we'll go ahead and pause for half a second or maybe even just a quarter of a second, and then try it again indefinitely. And as we read the lines in the file, we will send them to the channel. So here we're telling it to read to a new line. So read till you see a new line. In this case, we have to use single ticks. And we're gonna handle the error. So if the error is a end of file, we actually in this situation, we would just wanna sleep for a minute. And when I say a minute, we're gonna let's do 100 milliseconds, right? So 1/10 of a second. And then we're just gonna continue the for loop. Else if there's a different type of error, we will actually print that error to the console, and then we'll exit the program. And so now we'll have a line the line variable actually has a line of code here, or a line out of the log file. But we want to go ahead and cut the line feed character, or the new line character, out, so that we just have the line as itself. We don't want the line feed at the end of it. So let's go ahead and replace all of it. So we'll do line, and we want to catch the line feed. So we actually have the single line. So here we want to check to see if we have an output channel. If we have the output channel, let's actually send that cut line to it. Else, let's just print out we don't have no channel provided. And also, so here, let's also do a log. Let's print so we'll just print the line at the end, right? So just print it out if we have a line. When we use print out, we have to make sure we put a new line. We stripped out the new line here, but we just want to print it on the new line. So here, let's see what this is complaining about here. Oh, so it's saying error is not new, so we didn't need to redeclare it. So let's just see if this works, right? So now we're gonna build us a simple test to see if this works. So we just gonna do function main, and we're gonna say if os.args is equal to 1, then let's log.fatalf, let's send out not enough params passed in, right? And we need to do the length of the args, not just args. And os.args is anything that's passed as an argument to a command on this command line, and I'll show you that in 1 second. So if we only get 1, that means somebody just typed the name of the file and execute it, but we actually want them to type a file name. So we a file path. So we'll make the file path as args.1, and then from that, let's just grab that file streamer and grab that basic file streamer and pass in that file path. And right now we don't have a channel, so let's just pass nil in. All right, so let's run that and see what we get. See, not enough params passed in. That's because the param we want is the log file. So if you see here, we get no channel provided in the file. So we get an error in reading in the file. So let's go back and fix that. Oh, I put not equals here. This should be equals. let's save that and rerun it. So now we just see no channel provided. We should actually see the name, the log entry from the file. So let's troubleshoot that as well. So here, if the output channel is not equal nil, we do this. Oh, we put it inside of there. We just need to have it here so we can see what's coming in. Alright, so here you go. We can see that whatever is entering the file here, we can actually see it in real time. So this is August 18, 10:35, 25. And we can see that entering the file, streamed through this Go program and output it here on the command line. So that's working as expected. So let's marry this up to some type of web event to get it on the web page. Okay, so for this web portion, let's use Fiber to handle the web for us. So let's create a module called web. And let's create a new type, and we just gonna call it FS Web here. It's only gonna take two properties, and one is log, and we're gonna use our charm bracelet. But for right now, let's just define it, and then we're going to use a fiber app, right? So those aren't the packages we want. We actually want charm bracelet log, and we want fiber version 2. So yeah, so we can actually save that. And if we go here, let's go ahead and stop this and say go mod tidy here. After placing that as a dependency for this particular package or module, you'll see it installs it for us, and now we should be able to get some context sensitive help. So as part of this, we just gonna want to actually use this to start us a web server and serve us a static index.html page, and of course we're going to use event streams in this situation. We'll use event streams to stream this to the web page. So we will use Fiber to handle all that for us. So here we go. Let's create a function to get the web server. So here we're just setting up charm bracelet to handle our login for us. And we want to tell it to use timestamps, and we actually wanted to use the time.rfc 339 as the format for the timestamps. The only other part that we need here is for the WS, let's create a new Fiber app. So fiber.new, and then let's handle cores just because they can pop up from time to time. So let's just handle that now. So cores.new, and then we're just going to do a cores.config, and we're just going to use allow origins. We'll tell it to send the allow origins header with the star, and then say allow all the headers. Actually, we'll use just cache control for this. Okay. And also we want this to serve our static page. So we'll do a basic get for the slash, which is your root. And for this, we're just going to serve a static file. So before we complete this, let's create us a embed. So let's go here and create access.go. And I showed you this in the previous video, where you can actually embed static files into your Go app so that when you compile them, it will actually be in the binary. If you just include files or tell Go to read a file from a directory, by default it will not include that into the binary, so that file will need to be placed there along with the binary. But using these embed keywords and noting folders and things like that, it will actually go and compile that into the source code. So in this case, we want to index.html file. So let's create a static folder with index.html, and let's just paste in some HTML from before. And the only thing I think I want to modify, actually I don't think I need anything. Alright, so let's just leave that and go back to our web folder. So here, what we want to do is we want to tell Fiber to read data from a file. So we'll do data and set an error to assets, which is that actual module we created here at assets. Oh wow, it put it here. I don't want it here. I want it here. So let's move it out of there. Yes, move. Assets dot static file system, and then we want to just read a file, and the file we want to read is called static index.html, right? And if there's an error, we want to let the users know that we can't serve their web page. So we'll just send a status of 500 being a server error, because in this case it would be our fault. We would send a string and we'll say could not find static index.html page. Alright, but if we do have it, let's set the content type to HTML, and then let's return whatever was read in from the data, and that should get us our static file. Okay, and then at the end of this, all we need to do is return F. Alright, so perfect. Let's test that out. So to test it out, let's start the web server. So let's, goodness gracious, this new keyboard. So let's create this function as the start function, and it won't return anything. So all this is going to do is log fatal if f.fps listen listen on port 5200, or let's use 5100. I think we used that before. Okay, so let's just try this. So let's go back to our main here, and that's for right now. We can leave that. Let's just go. Let's send that as a go routine, and then here, let's just get a web server. So we can say get web server, and then we do at ws.start, right? It's giving you that because you're missing the module. Alright, so alright, perfect. So let's run this and see what happens. Alright, so we get this because we're opening a network connection, and if you look, we're still getting our log file at this point at 1048. So we're still getting the contents of that. So let's open the web page up to 5100, and we do have a web server here. So that's perfect. Nothing's coming through. So let's set up an event stream and stream this content coming from that file right into this web page. Let's create a new function. Let's say create event stream from channel, right? And let's just take a path as a string, and then let's take the stream channel as a type channel of type string, right? Let's get rid of this here. So pretty much copying again the example from the Fiber documentation, and I'll link that down in the description. But in this situation, we're gonna have data coming in on this stream, but we only have one. We would only have one channel outputting one stream. So as clients connect, we would want to create their individual channels and stream the data into that channel, and when the client disconnects, we want to close that channel and clean that up. So let's create us a streams variable that will hold all these different channels for all the clients connected. So we'll do streams, and streams we'll use make to create a map of int64, and it holds channels of type string. Then we'll do a var, and we'll keep a count of the clients. And we're going to create something called total messages, and we'll set that to 0. So now let's create a go function, a go routine here that actually takes any message that comes in off the channel. And so that's going to be the stream channel. And we want to increment our total messages every time we receive one. And then we want to actually iterate through all the streams that are connected. So in this case, that's everything in streams. and whatever comes in, whatever message come in, we just want to send that to that actual stream. Goodness gracious. Man, I don't know. VS Code is not my idea of choice, but let's see. Yeah. Okay, so as we have a typo right there. So as we receive messages on this stream channel, we're going to iterate through them and increment our total messages. We're also going to iterate through this streams, which is just a whole bunch of channels, and then we're going to actually send the message that we receive on this channel to every stream that's in this streams map here. That's all this Go routine is doing, and it will run indefinitely, or as long as this stream channel is open. So copy and code from the Go Fiber server send events again. Let's go here. Let's just copy that block. And then specific, it's all of this here. I just want to get this here. And we use f.ws here. And in this situation, we will use our path variable because we take in path as a string and stream as a channel here. So let's take that. It's saying we need fast HTTP here, so let's add that import fast. Alright, it makes that go away. So let's create us a integer that's just going to keep track of all the messages we sent to this particular client, because this is the client handler here. This will be all the messages this client receives. And so then we'll create an infinite loop on. Oh, before we do that, we actually need to go here and create us a channel. So we'll call this client channel. Then we'll increment the client count. Then we'll create a variable called myID, and that will just be the current client count. Then we will use that to assign this channel into the streams map. So now let's listen to that channel for messages. So for every message, you want to increment I. Then we want to fprint into W, which is the writer for the event stream, and we want to do an ID, and we're going to put the %d here. Then we want to write the data into W. And this will be the line coming from the log file. My message. Then we're going to actually flush that to the client. So that's when you're actually sending it to the network socket to deliver it to the client. If there's an error, you want to go ahead and log that error out. And so if this for loop breaks, that means we've lost the client channel. So we can log out a simple warning that just says client connection closed or broke. And then we'll put the client's connection, which was my ID. And then we want to delete this channel out of the stream. So we want to take that and use my ID as an index and delete that. And then we also want to close. If it's not already closed, we want to make sure we close out that channel. Actually, we don't need that, because if this for loop breaks, we'll cut that out. Then let's get out of that stanza, and then let's just return nil here. Okay, so that looks good. All right, so So let's see if this compiles here. Okay, so we're still in business. All right, so the other thing we want to this should be a D here. This should be a L. Save that. Okay, so let's see if we can't test this out. So let's come over here and let's make a channel. And we're going to pass in that channel here. And also here we're going to use our new function, create event stream from channel. And the path is SSE. And we want to pass in that channel there. So let's save that and give that a run and see what we get. Alright, so let's refresh this page here. And look, we have the lines coming from the log file in real time here on our web stream here, on our web page. So, pretty cool. So as we get in events from the log file, let me show you guys here. Let me show you. So tail -f temp some log, right? So as we get in the events into the file here, we say 652, 53, 54. As you get them, they appear right in the web browser in real time. So that's pretty cool. So what we did here is we're able to tell a file in Linux via a web page. So any file that's actively being written to, you can use this simple program to stream it to a web page. So I hope you guys enjoyed this video today. Thank you for viewing. Please remember, if this content provides value, click the like button, subscribe button, and the notification bell. Thank you guys. Have a great day.